All right, so check this out. This is going to be the tutorial for today, but let me show you some of the cool things that it can do. The idea was to create a tile where we can change the offset, we can change the pattern, and we can also see the changes of the area with some colors here. So what you'll learn in this tutorial is going to be how to take a square tile and then truncate it and subdivide it into a pattern like this. We then split the surface, array it using the count in series, which then led us to extracting the area for each of these and being able to give it a little bit of color here so we can see how the changes happen. Now, the reason why the color is different is because each area for those surfaces is different. So each surface is going to be calculated, and by changing some of these sliders, we can see exactly what happens. Now, this is just one exercise that we took in one particular direction. There are unlimited options and ideas that you can come up with to create a single tile to then array it. The other thing that I wanted to show is when you have one tile, let's say like this one, you can also develop it into a frame like this, or subdivided individual tiles like this. So this is perfect for many different applications. Like this could be a tile for a floor, for a wall, for a stained glass window, for a door. Really the options are unlimited. And so I want to share the whole process here. If you have any questions, let me know in the comments below. If you have any other tiling or pattern ideas, I would love to hear about those. Otherwise, stay tuned for other videos and let me show you the whole process here. All right, so to start this exercise, we need to bring in a reference rectangle. So what I'll do is I'll bring in a rectangle component, and this will give me the ability to create a rectangle here at the origin, and we can pick the size. So I'll go here to 5.5. And so this will give us a box that is 5 by 5 that we can change the size of. So this will become the module that we'll be developing. That way we can create an array and create a tiling pattern that we can change. So with this rectangle, we can now deconstruct it. So when you look at this rectangle output, you'll notice that we only have one polyline. So to extract and be able to use every single edge, we're going to go to explode. And this will let us explode that curve into 4 different segments. So what I'll do here is take an offset component, and we're going to be offsetting these segments. Now they offset to the outside, so we'll go here and bring in a negative component so we can offset it to the inside, and bring in a slider so we can pick how much it offsets by. So we'll do 1.500. With a few decimal points here, we can be a little bit more precise as to how much we want to offset this. Of course, when we go past it, it actually crosses over and out to the outside. So now that we've brought it in, now we need to shrink it. So what I do is bring in an extend curve, and instead of extending it, we're going to be shortening it. So the curve will go into the curve input. The start and end, well, we can just copy this, slide it over, tap Alt, and now we can extend it the opposite way, which would be shortening it. And if we use the same value, notice that it actually offsets it like this. So this actually gives you a clean offset, but that's not what we're trying to do. We're trying to keep these separate, and now these can be shortened like this, and they can be offset. So this is going to give us some control so we can change the pattern here. All right, so we have these line segments. We also have the original ones. Now let's go to endpoint, and we're going to pick and extract the endpoints of each curve. So we have 4 line segments. Each line segment is going to have 2 points, a start and an end. And therefore we can use those as well as the endpoints of the offset. So if I slide it, tap Alt, now we have these endpoints that we can connect. So I'll go to a line segment, go from start point to start point. Notice that this is dashed and this is a solid wire, which means that this is a grafted set and this is not. So now we can go here to graft, and now we see that it works in the sense that this endpoint connects to this endpoint. Now we're going to do the endpoint to the endpoint. And so what we've done now is connected those, and we can change these like this. All right, so now that we have these points, what we're going to do is bring in the center point of this box, or we can get the center point of those points because they're symmetrical. And one way to do this is to bring in an area component and use a rectangle, but I like to use this. The average will take the points and average the center point. So now we can go to, let's say, these points, plug them in, flatten the input, and it will be in the middle because when you average out these points, they average here in the middle and they won't change ever because it's a symmetrical offset. And so with that center point, we can now connect a line segment. And this particular line segment is this line segment that starts and ends at a particular place. So it's going to start at the center and end at these. Holding down Shift, I'm adding more inputs. All right. What we can do now is take a look at the entire design here. So it's this center portion. And the offset. We can also be very careful about the units we use. Like if the size of the box is 10, and then the offset is, let's say 5, and then, or 0.25. Let's see, which one would be better? 1.25. And then here we can also shrink it. So sometimes we can kind of play around with some of these to get a better result. We can also connect here to the midpoint. But for now, let's focus on these. And I'll show you, now that we have these curves, which are these, we're going to bring them together using a curve component so we can use those as a splitting mechanism for our surface. So I'm plugging all of these in, holding down Shift. They all go into this one. And sometimes when I route them all through one, it does create some confusion. So I'll go to Wire Display Hidden. And now let's go to our surface or our rectangle. We'll create a surface there. So I'll go to Boundary Surfaces. And we'll bring it over here because with this, now we're going to split it using the surface and the curves as the splitting of the surface. Now notice once again here that we have a dashed line and a solid line here. This means that for every surface, it's doing each curve once, and we don't want that. So we need to actually flatten this one. as opposed to what we did before, which was actually graphed the top one. And now we have the surfaces that have been split at those locations. This is the offset to the outside, and then this is the shrinking of it. So if we offset, if this is 10 from here to here, then to halfway is going to be 5, and then halfway is going to be 2.5, right? If from here to here is 5, this is 2.5, so we're kind of splitting it in half. And then if that is 1 and we split it in half like this, 4. Okay. Now with this, we're going to tile it. So the idea here is once we've set one module, now we need to take this module and copy it to see what it looks like with a tile, because what it references next to it actually helps you visualize the whole image that it can create. So with these fragments, now we need to move them both in the X and Y direction, and we have the size here. So we know that it's in 10 in the X direction, 10 in the Y direction. So how do we do this? We'll go to a move component. We'll bring in also a series component because we need to move it to create an array more than once. So series. The step by how much it's going to increment has to be the size of this, so it tiles right next to each other. So step is going to be 10. Count, how many do we want? We'll go 1 less than 15. This will give us a slider from 1 to 15, and now we can set this here. I'll just go to 3. Now in which direction? Well, this is going to be first in the X direction. So this, and now we're going to move all of these fragments, and we're going to graft the input. Now that we have this, we can extend that tile to the right. And now we're going to do the exact same thing, but copy this, put it here. So we're going to copy the output, which means all of these, but the motion cannot be in the X direction. It actually has to be in the Y direction. Otherwise it's going to overlap like it's doing here. And now we can override this here. So we'll disable the preview on all of the stuff before, including the pattern. And now when we look at this, we can expand the tile and we can really visualize what's going on here, because at some stage you're going to get a circle. So notice there, if you pick the correct numbers, you can get different patterns. And the important thing about this is that we can change a slider and we can see exactly the changes that it's making, and we can make a better decision. Now this is just here using the offset. So notice that this line segment that we offset and shortened, that is what we're working with here. So let's say 3. Then the shortening of it. So this actually expands it out. So there goes too far. Maybe this is a little bit too far. I think that's looking good. So with this pattern, we can play around, have some changes, some variation, And at the end, we can have this tile that we could use like this, or we have other possibilities. Let's go back here. Like this. Notice that this is the fragment before we went through and arrayed it. So this is the array. These fragments we can also offset in the negative direction, because when you offset, it'll go to the outside. And if we just say 0.25, 0.125 or so, like a small offset. So you can see that we can also turn these into stained glass frames that we can boundary surface between this and this. And we actually need to graft this one because this one's dashed solid line. So on this one, I'll actually use the component graft tree. And now we can disable the preview on this stuff. These are going to be separate panels, but we can also join them. Flatten the input, so it gives us one brep, and then merge coplanar faces, which means it gets rid of that middle crease. So this gives us that ability to create a frame around it like this. And what does that look like tiled? Well, we can take this input. I'm going to wire display hide the input for these because they're all the way to the left here. And now we'll take this, copy it down, and plug this one in. Now this will give us the tiled version of it, or the framed version of it. So now with a script like this, we can go through and pick out and see all of the different options that we have. So this is one option. That's one option there. Then there's this option. And lastly, we're going to do this option. This one that has each panel separate, which is different than this. So I'll go to this one. This is different than this because it doesn't have each individual piece, which could technically be a tile, right? If you created this pattern and wanted to create it into a floor tile, well, you can cut these as specific tiles and set them in, where this one, this would be the whole tile next to the other tile. So this shows us all the options. And so what I'm going to show you now is how to add some color to this. So far we've gotten this far. Now let's get into, once you have the design, how you can display it. All right, so the first component we'll bring in is the gradient component. And this needs 3 numbers. The start number, end number, and then the number that the color sits on. So with this geometry, how do we get 2 numbers? Well, we know that these tiles are not all the same size. The area of this triangle is different than this one, different than that one. And so for us to be able to extract that, we need to deconstruct domain. And this is going to be whatever numbers. So if we're going to deconstruct the area. I didn't bring that in yet. So we need to also bring in the area component. This will calculate all of these surfaces and their area. And depending on their area, we're going to be able to extract. So this area goes into the domain. Now we do need to flatten the input. So now we have a start of 0, an end of 11, and those are the start and end points you use here. Now, since the end is 11.36, whatever number that is, we know we need to create a parameter number. So we'll go to 5.50 and set this one as the parameter input. Now, nothing's going to happen here because we need to apply it using a custom preview. Custom preview we can use to plug in the geometry that we want to preview and the color assigned per area to each object here. Now, here's the thing that I didn't mention. I do need to flatten the input both for the graph, for the input. I need to flatten it, and then it'll work, because like I said earlier, when you have dashed line and a wire here that's not dashed, actually this is a different wire. This has multiple data points, but they're all in one list. And this is a bunch of different sets. With that being said, now we can create some color here. And by default, the first one here is going to be this color. We can change that here as well, but we can also go to different presets. And now, if you don't like the display color, well, we can change the range, whether it's going to be at the beginning or towards the end. And the thing here that you're going to see is that the color is different due to the area. So if we offset this, let's say further, you'll see that we have different areas, and you start seeing that the area for those, although the shapes are different, the area is very similar. And so this is the way to do that. Now let's change this one last time. And this one's cool because you can see the change, subtle change of them here. Let's pick an interesting color one here. And let's change some of this stuff around. And so, in my opinion, what makes parametric design a really interesting tool to use for creating patterns is that you can see the changes right away. And therefore, you can make better decisions rather than having to pick one of these numbers at a time and then see the output. We're going to do the same thing to the other ones. So I'll take this, slide it down, tap Alt, and let's see what happens with this one. Now we can disable the preview on this. So I figured out why on this one, they're all the same color. And that's because each individual tile, it's one area. So they're all going to be consistent, and that makes sense. So now let's try that down here with these tiles that are all separate, yet the area within them is also the same. So the area inside of this, the area inside of that, and the area inside of that are the same. And that's what is a little bit strange about this, is that the only one that will give you separate colors is each individual tile that has a separate area, which would be this one. So I'm going to disable the preview on this one and keep it previewed on this one. Now we can change this down as well. Notice that the range has to be between 0 and 11. So I need to change this one to 11 or 12. And that's also going to change because if the area changes, then this will change. So with that being said, I will be sharing this with you guys if you want to download it on my website. But the important thing is that you guys are able to follow along with the tutorial learn a few tricks and techniques so you can use this program for your designs. Now, a lot of people tell me, hey, I don't need to use parametric design. And for people that think that they don't need to use it, I would say you don't need to use it. But if you want to get better at designing, if you want to be able to see all of your options, if you're bored with just traditional 3D modeling, give this a shot. You'll be surprised at what you can create with it, and also how powerful it can be. Because I tend to use it for practical things like designs and stuff like that, but people use this program for so many different things that has to do with data, that if you're intimidated, give it a shot. Okay, I'm going to clean this up and have it available. If you have any questions or you want to learn more, I have more tutorials. Check out my website if you want to download this. Otherwise, stay tuned. I will be posting more videos about parametric design, pattern stuff, architecture stuff, random design stuff. So stay tuned, and I hope to see you on the next one.